All right, it's time to talk about balancing equations. Ready? Let's get to it. All right, let's review what you should already know. So this is the foundation to be able to balance. So first, we have chemical formulas, okay? We cannot balance with words. We need the chemical formula. So helium, for example, would just be He. Oxygen and the other diatomic elements would be O2. And then we have compounds that are composed of two or more different elements, like water, which its chemical formula would be H2O, carbon dioxide, CO2, and so on. We can identify states of matter in equations by looking for the symbol after the chemical formula. So a G would indicate gas, an L would indicate liquid, an S would indicate solid, and AQ would mean it is dissolved in water. And we will focus on that a lot when we get to the solutions unit. All right. The difference between coefficients and subscripts. So coefficients, like in math, are the big number in front of the formula. So 2x, the 2 is the coefficient. In a chemical formula up here, the 2 in front of the chemical formula, that is the coefficient. Subscripts are lower numbers, small, found after the symbol. So this 2 after the H indicates there are 2 H atoms in the molecule. And this indicates there are 2 of these whole H2 molecules. When there is no coefficient present, that means the coefficient is 1. When we count atoms, we have to take into account subscripts and coefficients. So this subscript applies to the element directly in front of it, so the H. So when I count the number of H atoms, I need the coefficient times the subscript. When I count oxygen, there's no subscript, so it's a 1. So I need the coefficient times 1. And here, when I have a subscript outside of parentheses, I'm going to have to do multiple steps, okay? So there's 3 SO4s inside there's 1 SO4 inside the parentheses times 3 times 2. For oxygen, it's more complicated. 4 inside the parentheses times 3 outside the parentheses times 2. Everything gets multiplied by the coefficient, no matter if it was inside or outside the parentheses. And then aluminum would just be 2 times 2. Okay, arrow, we say it is yields. So this is N2 plus 3H2 yields, not equals, yields 2NH3. Reactants versus products. So here we have the yields sign, the arrow. Reactants are on the left side, products are on the right side. And you can see this one illustrates how in CH4, the bonds are being broken. In oxygen, the bonds are being broken. And on this side, new bonds are being formed. Exothermic versus endothermic. So endothermic means heat or energy is being absorbed, and on table I, that will yield a positive value. Exothermic means heat or energy is being released, and that means on table I, it will have a negative value. All right, so kind of putting it all together, we have reactants on the left side, yield, products on the right side, we have subscripts, we have coefficients, which indicate the number of molecules, the subscripts indicate number of atoms, and we have states of matter. Now, let's get to balancing. Are you ready? Okay, important thing. Never, ever, 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 ever change a subscript when you're balancing. You can only change a coefficient. Why? A coefficient simply changes how much of a substance you have. So change the coefficient. I had water, I put a 2 in front, now I have 2 water molecules. If I change a subscript, I completely change the substance. So if I put a 2 down here, I just changed water to hydrogen peroxide, and nobody wants to be drinking that. So you cannot change subscripts to balance. You and only change coefficients. So let's look at a virtual example first. Are you ready? Let's try balancing. You can see all of the coefficients are 1, which is what I'm starting with. And I have the numbers counted down here, but also you can see it tells me over here. So you can see that before and after, hydrogen is balanced. There's 2 on the reactant side, 2 on the product side. Beautiful. But after, oxygen has 2 on the reactant side, but only 1 on the product side. So maybe if I fix the oxygen, it will fix it. So I want to go to the product side. Here is oxygen. I'm going to change that number to 2 by changing the coefficient. Here's the problem. When I change oxygen over here, I also change hydrogen. So that you can see while oxygen was fixed, hydrogen was not. So now it is still unbalanced. So let's try and fix hydrogen on the reactant side, and voila, it is balanced. 4 hydrogen on the reactant side, 4 on the product side. 2 oxygen on the reactant side, 2 oxygen on the product side. Another one, you can see right now that is definitely not balanced. So let's show our histograms down here with the numbers. You can see aluminum is balanced, let's not start there. Chlorine is not balanced, and neither is hydrogen. Okay, so watch this. If I fix hydrogen, so if I make it be 2 hydrogen on this side, 2 on this side, well, that messes up chlorine. So then if I change this to 3 for chlorine, that messes up hydrogen. So in this case, I might not be sure where to start. So a good rule is when it looks like you're struggling, try and put a 2 in front of the most complicated looking formula. So that looks like this one right here. So let's put a 2 in front of this one and then try and balance everything else. Okay, so that means I need 2 aluminum. Beautiful. I need 6 chlorine though. So let's see, I need 6 chlorine before. So there. Okay, and then I just have to balance hydrogen. So let's see if I can do it. And there we go. Voila. See, so a good rule, a good attempt is to try and put a 2 in front of the most complicated looking thing and see if that helps out. Okay, let's try another one. Let's show our histograms with our numbers. And this is decomposition, breaking down. You can see right now it looks like the only thing that is not balanced is chlorine. Now, normally you're not going to be making a graph. You're going to make just a table that lists the elements and counting them. So let's try balancing chlorine, which means I need 2 chlorine to be on the reactant side. So when I do that, that's a problem because it also messes up Na. So you can see chlorine is perfectly balanced now, but sodium is not. So can I fix it? Absolutely, easy enough, easy peasy. This one is balanced. All right, here we go. Let's show our histogram and let's look. So remember, this is the same as making a list in a table and seeing what is balanced and what is not. So you can see I would not start with sulfur, I would not start with chlorine, I would either start with hydrogen or with sodium. So let's just start with sodium and see what happens. So I have 2 sodium on the reactant side, but only 1 on the product side. So let's change it. Okay, when I do that, it fixes sodium, but it changes chlorine. So that's no longer balanced. Sulfur is still fine, so let's leave it alone. And in fact, everything on the first 2, so sodium and sulfur, are balanced, but hydrogen and chlorine are not. So you can see on the reactant side, I only have 1, but on the product side, I have 2. So let's try and change on the reactant side to add another hydrogen. And when I do that, it also changes chlorine because they're in the same compound, and voila, it is balanced. Okay, let's try another one, combustion. Now, I haven't really been focusing on the type of reaction in this case, but if you want to review types of reactions, this is also a great place to go. So let's look. So I have carbon, balanced, hydrogen is not, oxygen is not. Normally, I would say this is good. I have a 2, 3 for oxygen. I will start by making the 3 even and multiplying it by 2. So when I look up here to try to find the oxygen that has 3, you'll notice it's not there because oxygen is in 2 places. So I think I should follow the rule where I just put a 2 in front of the most complicated thing, which in combustion is always what is being burned. So let's put a 2 here. And now let's try and balance everything else and see what happens. Okay, so let's do carbon first because that is an easy one. It's in one spot. Let's do hydrogen next because it's in one spot. So I have 8 on this side. I need 8 on this side. So like that. Now I don't want to change this hydrogen, right? So let's try and change oxygen here. Okay, I got it balanced. It's true, but let's look at these coefficients. 2, 4, 2, 4. They can all be divided by what number? 2, right? So let's divide them by 2. 2 divided by 2 is 1. 4 divided by 2 is 2. 2 divided by 2 is 1. And 4 divided by 2 is 2. So you can see it's balanced and the correct coefficients. Okay, there we go. All right, now that we've gone through those virtual examples, let's try it ourselves. Okay, so you were given a guide that looks like this to kind of help you through it if you're struggling. So here we go. Let's try some examples. All right, so here's our equation, and I'm using the guide that you were given. You don't have to set it up like this, but it does help. So I'm going to write my list of elements. Notice that I'm going to keep hydrogen here and here. Now, I do need to add them together because that's what matters. I need the total number of hydrogen atoms the same on both sides, but keeping these separated because they're in different formulas will help, okay? And I'm just going to make the same list of elements on this side. Now, I did not duplicate H because H is only in one formula on this side, but I still have the same list of elements. So now let's go through and put in our subscripts. So these are the numbers that are in the formula. Remember I said I had to keep track of the total H's? So that's what those arrows, and that's what that little 2 to the side is for. Let's check on this side. Okay, so what do we notice? Literally everything is balanced. It does show conservation of mass, so I'm done. Now, I don't add any coefficients. There is a coefficient in front of 1 in front of all the formulas. So technically on an exam, if you put a 1, it would not be incorrect. But one thing you should never write is don't put a 0. Literally, if you put a 0, you just erased what was there. So don't do that. Okay, so leave it blank if it's a 1. If that stresses you out to leave it blank, put the 1. Okay. All right, so let's try another example. Let's make our list of elements. Both sides the same. It's not in multiple places, so that makes it a little easier. Let's check the subscripts to put the number of atoms in the element. You can see I don't have it balanced. So you can see that sodium is not balanced and oxygen is not balanced. Okay, I'm going to choose to start over here. Okay, and I'm going to start with oxygen because it's in a compound. So when I change this oxygen, I know it's going to change sodium. So it's better to start with it first. Okay, so starting with the compound where you need to balance is a better idea. Okay, so I balance oxygen, which means I need to put a coefficient of 2, okay, if it works. All right, now I'm going to also multiply the sodium by 2 because it's in the same formula. Okay, now let's check the other side. Well, oxygen is fine, but I need to balance sodium. So now all of the atoms are balanced. It shows conservation of mass. So add the coefficients that were from here. Okay, so the coefficient of 2 for balancing oxygen changed sodium, which is why we had to end up doing a coefficient for sodium as well. All right, let's try another one. Looks a lot more complicated. So let's make my list of elements. Okay, now the reason I wrote H and O twice is because they're in two different formulas, but I am going to need to add them up. So on this side, only O is in two different formulas. So let's write our subscripts. Now oxygen is 3 here because it is inside the parentheses, but I have to multiply it by 3. Same for hydrogen. Okay, but remember I needed a total, so I have 5 total hydrogens and 6 total oxygens. So let's see what I have on this side. Okay, so this looks like really complicated, right? Okay, so where am I going to start? I'm going to start with H on the reactant. It's an odd, even pair type situation. So you can see 3 on this side, but it's a 2 on this side. Okay, I'm never going to get that to work unless I get this to be even. So by doing that, I'm going to put a 2 coefficient up here. So I would be doing this right here. When I do that, you can see it changes hydrogen, but also changes oxygen and aluminum. So let's do that. Okay, so now let's see what happened. Well, good, look at that. That fixed aluminum. That's a good sign. Okay, but it changes our number of hydrogen total and oxygen total. Okay, so that didn't fix anything else. All right, so now where am I going to go? Let's try and do C next. I have 3 on this side, but only 1 on this side. So let's try putting a 3 here. Okay, so let's try that. When I put the 3 here, it changes hydrogen and also oxygen. So let's change those times 3, change my hydrogen total and my oxygen total. Whew, oh my goodness. Okay, that's a lot. So aluminum is balanced and carbon is balanced. Oxygen and hydrogen are a hot mess. Okay, so let's try and do hydrogen because it's only in one spot. So hydrogen, my total hydrogen is 12. So I need to have 12 over here. So when I do that, put a 6 there. It also changes that oxygen, right? So when I do that, oh, okay, I accept that. That's awesome. It literally fixed the oxygen. Thank goodness, because it was looking like a wild situation up here. So let me just erase these so that when I put the numbers up there, it will not look a mess. So it shows conservation of mass. Put those coefficients back that I had. In this blank, right, there would be a 1. So if it stresses you out to leave a blank, write the 1. You won't get it wrong. But never, ever, ever put a 0. You literally would have just erased it if you did. Don't put 0. Okay, so let's talk about a couple things to remember. Coefficients must be in the smallest whole number ratio. What do I mean by that? Okay, so we balance it, we get this. The ratio is 16 to 3 to 8. I look at the coefficients. It's the simplest ratio. I can't reduce it. I can't divide 16 and 3 and 8 by anything except for 1 and keep them whole numbers. So that's it. But let's look at this one. So I balance it and I get this. My ratio is 6 to 2 to 2. This is not the simplest ratio. I can divide each coefficient by 2. So the reduced ratio is 3 to 1 to 1. So the equation balanced would look like this. Remember, you can write the 1s if it stresses you out, but never, ever, ever write a 0. There must be conservation of mass. So that means the total number of atoms of each element must be equal on both sides if it's balanced. Be careful when an element is in more than one formula on the same side. So remember, I wrote it twice and then kind of off to the side totaled it. because it can get a little bit complicated, because if you're putting a coefficient in front of one, you're only changing it in that formula, not the other formula. So I like to keep them separate and then just add them off to the side. Remember, balancing an odd even pair is a good place to start. So there were 3 hydrogen on this side and 2 hydrogen on this side. So a good place to start would be to make this 3 even by multiplying it by 2. Okay, so that's a good place to start. If you're struggling, putting a 2 as a coefficient in front of the most complicated formula is often a great place to start. When it's combustion, meaning burning with oxygen, you put a 2 in front of the thing that's being burned and start there. Otherwise, try it in front of the most complicated thing. If that didn't help, try a 2 in front of a different complicated formula, okay? Now, you may have to reduce the coefficients at the end, but it's better than struggling. In this case, because this is an odd number, I don't have to reduce. But putting that 2 sometimes means you have to reduce everything by 2 at the end, but that's not a big deal. So a big part of balancing is practice, 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 which is what we're going to do. And there you have it. That's balancing equations in a nutshell. I hope you learned something new today.